In this lesson, 6-4 rectangles, we are going to prove and apply properties of rectangles, determine whether or not it is a rectangle. So we have two warm-up problems over parallelograms, so go ahead and try 1 and 2. If it is a parallelogram, which it is, we know here in the directions, then we are going to apply some of those properties. So we know that opposite sides are congruent, and we know that consecutive angles are supplementary. So we're going to add up those A and B and set it equal to 180 and solve. So push pause and try it, and then play and check when you're ready. All right, so setting those opposite sides equal, we get 3 for Y, and we plug it back in for CD to get 14. For number 2, we add A and B together and set it equal to 180. And then we solve to get 5 for X. We're looking for angle C, which we know is going to be the same as angle A because they're opposite. And so we plug it in for A, which is the same as C, and we get 104 degrees. So the first type of special quadrilateral we talked about was a parallelogram. And now we're going to learn about the second type, which is a rectangle. And a rectangle has two properties. It has opposite sides, parallel and congruent. With 4 right angles. And then this one, the diagonals are congruent. And really this one comes from parallelogram, so we don't actually have to kind of write that out, because if it is a parallelogram like it says, we already kind of know that. But the 4 right angles is kind of the specific one to our rectangle, which is our definition. So thinking of those two properties, as well as it inherits all the other properties of parallelograms, kind of like we talked about up at the top, it's going to have all those other 5 properties in addition to these 2. So we know that these are all going to be right angles, and we know that the diagonals are going to be congruent. We also know that the diagonals bisect each other if it is a parallelogram. So if these are congruent and they bisect each other, then these are all these little halves here from BE to EC to AE. Those are all going to be the same. So for BD, if I want to find the whole length and I know half is 6.5, then I'm going to double it. And I know that BD is 13. CD is this opposite side here, which is going to be the same as the 5 that it's opposite from. So 5 inches for that one. AC is this diagonal, and we know diagonals are congruent. So if this diagonal is 13, then this diagonal is 13. And then AD is this side here, which is opposite your 12. So it's going to be 12. All right, so let's take a look at this next example. We have angle RTU, which is 8x plus 4, and angle SUR, which is 3x minus 2. And we want to figure out what x is. Well, these angles are going to be the same here, and these angles are going to be the same here. And together, this angle and this angle, they form a corner. And we know a corner on a rectangle, they're right angles. So together, these are going to add up to, so this one, 8x plus 4 right here, and the 3x minus 2, this little one, those are going to add up to 90. So 8x plus 4 plus 3x minus 2 is going to equal 90. So we can add our x's. They're on the same side, so we just combine like terms. Add the 4 and the negative 2. And now we can do our two-step equation solving after we've combined those like terms. 11x is equal to 88, and divide by 11. So x is 8. So again, the right, or corners, are right angles on a rectangle, and it tells us it's a rectangle right there, so we know it has all those properties. Okay, so again, here's a corner. We know it's a rectangle, so it's going to form that 90-degree angle. And I know the measure of angle 2 here is 36 degrees. So if this one's 36, what is this one? Well, 90 minus 36, and so it's going to be 54. So if we have at least one right angle and it's a parallelogram, then we know it's a rectangle. We only have to have one and know it's a parallelogram, and boom, that makes all the rest of them right angles, and we've got a rectangle. If we know the diagonals are congruent and it's a parallelogram, then we know it's a rectangle. So those are kind of our two properties going in reverse to prove if it's a rectangle. So is A a rectangle? Yes. We have one right angle. Now we do need to, I think it meant to say parallelogram besides quadrilateral. So we're going to go ahead and kind of put up here that these are parallelograms. We're just specifying if it's a rectangle or not. So this one, it's not opposite sides, it's the sides next to each other, so this would be a no. And then this one, these diagonals bisect each other and they're congruent because those tick marks. So that is going to be a yes. The diagonals are congruent. All right, so this last problem here, we're going to verify that it's a parallelogram by finding the slopes of these sides and making sure that they are parallel, going up at the same rate. And then we're going to verify the length of the diagonals. We're going to do kind of what we did in our last 4.8 lesson of actually calculating the length of that using kind of our leg squared, to make sure that they are congruent. You can also double check and just find their slopes and see if they or kind of find one right angle if you wanted to with the sides. And then you could do it that way. If you don't want to have to calculate length, you could kind of just do your slopes of this side and see if it's a right angle. So that might be a little bit easier. All right, so let's go ahead and do rise over run, 1 over 3. So for J, K, it's 1/3. And then let's check this one down here that's opposite. 1 is the rise and 3 is the run. So that makes it parallel to ML. So there's one pair of opposite sides parallel. And then let's check our opposite sides over here. So down 1, 2, 3, 4, 5, 6, -6 over 2. And -6 over 2 is the same thing as -3. And that slope is JM. And then our KL slope over 2 down 2, 3, 4, 5, 6. So again, -2 over 6 or -3 for slope KL. So these are parallel, and so we do have parallelogram. Yes, it's a parallelogram because both pairs of opposite sides are parallel. And then let's go ahead and check our diagonals. So I have to draw those in because they're not drawn in. So I'm going to go straight down, straight across, and you can calculate this by going from vertex point to vertex point, and you can find the length by doing your leg squared, or you can just find the slope of this line, which you already actually know, and the slope of this line, which you already know. So 1/3 and -3, and are these opposite reciprocals? Yes, perpendicular, which makes 90-degree angle or a right angle. So yes, comma, this is a rectangle. So if you didn't want to find the length of this diagonal and the length of this diagonal to see if they're equal, you can find the slopes to see if this forms a right angle or any one of these. And that is another way you can prove it's a rectangle.